Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we are going to talk about the purification of organic compounds. Okay, so in this class we are going to discuss about the different purification techniques that can be used to purify a compound. Okay, so let's get started here. You can join our WhatsApp channel, link is there in the description section. Okay, so today we are in the part 6, that is purification. Okay, in the next class we'll do quantitative and qualitative analysis. Okay, this chapter has not much weightage directly, but as you all know, this chapter is used regularly in the in your PU2 syllabus. Okay, it is very important to understand the fundamentals of organic chemistry, so this chapter is a must. You cannot afford to skip this chapter. Okay, so yes students, now I want to tell you about something very important, that is PU2 success blueprint test series. And in this I want to tell you, because Christmas is coming, right, and we all are your Santas, and we have brought something very special for you. So you can get a discount of flat ₹100 on this particular price if you use our coupon codes. Okay, so if you use, you can use the coupon code. I'll write you the coupon code here. Okay, if you use this coupon code, okay, AISH100. Okay, if you use this coupon code, then definitely you will be getting ₹100 off, and the prices will come down to $499. So this is a Christmas offer which is valid only till 28th of December 2024. So make sure that you grab this opportunity and make the best use of this time and buy this particular test series as soon as possible. Okay, after the Christmas is over, the discount period is over, again the prices will go high, right? So make sure that in this Christmas we will take a step together towards our success. Okay, so and all other details of the test series you can see. So let's get started with the class. Okay, so now coming to this one. Okay, so now in reaction, okay, one second. Yeah, so sorry, this in the purification topic. Okay, what all things are we going to discuss today? So first thing that we are going to discuss is why purity of compounds is required. Is it really essential? Then what are the different types of impurities we have? What are the purification methods we have? And here we are going to discuss the purification methods in detail. Okay, sublimation, distillation, crystallization, chromatography and differential extraction. Okay, so let's get with the first one, that is why do we need to purify the compounds? So it is because to remove the impurities. Okay, now important for identifying and analyzing the compound. If you want to study a compound, it should be in its purest form. Okay, otherwise the properties that you are studying may be affected by the impurities that is present in the compound. So that is why it is very important to purify the compound and then go and then analyze it. Next one, it enhances the quality for further use. Now different products are like whatever products in a chemical reaction are synthesized, right, they are used for different purposes. But if the product that you have obtained is not purified or is having a lot of impurities, then it cannot be used for further processes, right? So you can see generally when you have some raw materials, they undergo reaction. After reaction we do purification and then the final product is obtained. Okay, so that is the importance of purification. Now coming to what are the different types of impurities. So impurities are generally of 3 categories. One is mechanical impurities, which is like normal dust and sand, which you can remove easily through the physical methods of separation. Next you have soluble impurities, which is unreacted towards the starting material, and they are like, what are these soluble impurities? The reactant that you have used, okay, there some of that remain unreacted and some byproducts are also formed with the reaction, right? So these are all your soluble impurities, and then you have insoluble impurities also formed. Okay, so next coming to the methods of purification. So the methods of purification is of 2 types, that is physical and chemical. Under physical we have sublimation, distillation, crystallization and differential extraction, 4 methods. And under chemical method we have chromatography. Okay, we are going to study all these methods in detail. Now coming to the first method, that is sublimation. Okay, sublimation is what? It converts the solid to gas. Okay, the solid form directly gets converted to the gas form without going to the liquid state. Okay, so now what happens? It is used for purifying substances like naphthalene or camphor. Okay, now example is mixture of sand and camphor. So here you can see, for example, we have taken ammonium chloride. Okay, when it is heated, okay, the solid, the ammonium chloride is now having some impurities in it, right? But the impurities do not undergo sublimation, right? The ammonium chloride can undergo sublimation, and the ammonium chloride present here will directly convert into gaseous phase, and after cooling down it will cling or it will attach to the walls of the vessel. So you can get the pure ammonium chloride in this particular section. Okay, so that is the method of sublimation. Next we have distillation. Okay, so distillation are of again three types. We have simple distillation, fractional distillation and steam distillation. Okay, now what is the simple distillation? So it is used to separate liquids with significant boiling point difference. Okay, so suppose you have two liquids A and B. Okay, they are mixed with each other and you want to separate A and B, then you use simple distillation. So what is done? See, here there is this is called as a round bottom flask, and here you have both the liquids A and B, which has a significant difference in their boiling point. Now when you heat them, okay, the one which is having lower boiling point, okay, will boil first. So that, like suppose liquid A will boil first and go here, and then it will condense. This is a condenser, so when you pass this, so here you pass water around this tube and that gas gets condensed and we get pure liquid A on this side and pure liquid B will be remaining here. So when you have a difference in the boiling point, you can use simple distillation method. Next one is fractional distillation. It is used when the boiling points of the two liquids are very, very close. Okay, so what extra we use in fractional distillation? In fractional distillation we use something called as fractionating column. Okay, so when the two liquids A and B are there, okay, and you are boiling them or you are heating them, then both A and B will evaporate. Okay, now what happens in this fractionating column? There will be one which will condense and the other one will form vapor. Okay, so the one which is having higher boiling point, right, the one which is having lower boiling point will condense here, and the one which is having higher boiling point will pass here and will be collected on this side, right? So that is how you can separate two liquids which is having similar or very less difference in their boiling point. And you can see the fractionating columns can be of any type. These are different types of fractionating column that is used. Okay, do not have to know much in detail. The only thing you should know for fractional distillation is it is used when the two liquids have very less difference in their boiling point. Next is steam distillation. Okay, so this is for your steam distillation. Okay, so when do we use steam distillation? Okay, so one very important application of steam distillation is extraction of oil from flowers. Extraction of oil from flowers. Now see, if you heat the flour to a very high temperature, the oil that is present may get damaged, okay, or may get spoiled. So to prevent that, what we do, you can take the dissolved flowers here, okay, you can just put some water in the flowers and take here, and you allow the steam to pass through this. Okay, so when you allow the steam to pass through this solution, the steam will extract the oils from the flour and will pass. Okay, so now we have got condensed. See, here you are giving some condensed water vapors. Okay, you are putting the condensed water vapors to this one, and this you can see here condensed water vapors are given to the tube, and here you have taken a mixture. Let us imagine that you have taken flour solution. So these vapors will extract the oil from that and will come out of this tube. Okay, and now you can see there is a condenser here, right? You can this can be collected here, and next this one will be condensed here. Okay, I hope you are understanding. See, once again I'll tell you. Let me explain this one properly. Okay, see, suppose you have taken a flower extraction, okay, you have just imagine you have grinded one flower, okay, you have blended one flower so that you got the juice of the flower, okay, but it has what? Oil in it, the fragrant oil that we used in different perfumes and all, right? That oil is present in that flower. Now how can you extract that? So just see, this is the so that blended flower juice you have kept here, okay. Now here water is there, this water is undergoing, you are heating it, right? So it will form vapor or steam, and that steam is passed to this particular tube, this particular flask, where you have the compound which has to undergo distillation, or where we have to extract the oils. Now this steam reaches here, okay. Now this steam will extract the water, extract the oil from this, and will go out from here and reach this condenser tube. Now in this condenser tube, what will happen? The water will condense and the oil will condense, because oil and water are inseparable, or sorry, water and oil are immiscible. You can find two different layers, and then you can filter out and get the pure liquid or the oil from the flowers, okay. So why cannot we use the direct method of distillation here? Because if you give more amount of heat, the oil that is present in the flowers will get destructed or will get spoiled, okay. So you need to give small amount of heat, and that is obtained through the presence or the production of steam, okay. I hope this is clear. You are heating here, this is producing steam. This steam is passed to this container where we have the substance from where the gas or from where the oil has to be extracted. Now this steam takes this oil and comes here, and then it gets condensed. Water and the oil both gets condensed and get collected here, okay. Next is coming your crystallization. Crystallization is very basic principle of getting. So what is it is used for? Solubility of solid increases with the increase in temperature. So what is the step? First you dissolve, okay, then you filter it, then you cool it, then crystallization takes place, and then you separate the crystals, okay. It is used for sugar and salt purification. I'll explain the steps here. You can see, suppose here you have the impure solid is dissolved in a solvent, okay. This solvent is there where the impure solid you want, for example sugar or salt, which you want to purify, you have dissolved in it, okay. Next what will happen? The solution is heated to evaporate most of the solvent, okay. So you keep on heating the solution so that most of the solvent is evaporated. Next, the hot solution is allowed to cool. The solid appears as pure crystals. Now what will happen when you allow most of the solvent to evaporate? Very condensed or concentrated solution is there, you allow to cool down, okay. So when you allow to cool down, the solid that is dissolved in this particular solvent will be crystallized, okay. Now you can remove that and you can dry it and purify this one, okay. Pure crystals can be obtained in this way. Next, coming to chromatography, very important purification method. The separation is based on the movement of stationary phase under a mobile phase, okay. We'll discuss what is stationary phase and what is mobile phase. Now there are two types of generally chromatography. One is adsorption chromatography, another is partition chromatography. In adsorption chromatography we have two things, that is thin layer chromatography and column chromatography, and partition chromatography is another type of chromatography. So we will understand thin layer paper and column chromatography first, okay. So coming to paper chromatography, I think most of you would have used this experiment in your class also. So what you can see, imagine you draw a dot with a marker on the piece of paper and dip the paper into water. The water travels up the paper and pulls the color apart. So you can see an example here. You can see this example. You have just put a drop in this particular paper, okay, and then you have dipped it in the water. Now what will happen? As the water will rise through the paper, it will pull some of the colors, okay. You can see the colors splitting out, okay. So now once you can see different, suppose red color has moved to this much, 6 centimeter is for purple, you have 8 centimeters for blue, and 10 centimeter is the solvent has moved this much distance, okay. So that is how you can separate the dyes present in the ink, okay. Now if you see what I can say, this distance, there is something called as retardation factor, okay, retention factor, sorry. So this distance is what? Distance covered by the dye, okay, divided by the distance covered by the solvent. Okay, so I can write in this way, suppose RF, and I want to calculate for red color. So that will be equal to distance travelled by the red divided by the distance travelled by the solvent. So that is 1 by 5. Okay. Next, how it works, see. Now some color in the marker ink move faster with the water and go higher on the paper. Others are slower and stay lower. Okay, so the one which can moves fast with the water solvent goes up, and the one which is more attached to the paper than to the water, that will move slowly. You are pulling that very with difficulty, it will move slowly and it will stay lower. Okay, next, where it is used, to see what colors are mixed in a pen, candle or even plants. These are the uses. Next, let us see thin layer chromatography. This is also very similar to the paper chromatography, but in paper chromatography the stationary phase, the stagnant phase is used like a paper, but in thin layer chromatography we generally use silicon dioxide as a stationary phase. Okay, so it is a paper chromatography but done on a glass or plastic sheet coated with a thin layer of powder like chalk dust, or you can say silicon dioxide. Okay, now the same thing, the liquid solvent moves up the sheet and carries different chemicals along with it. Each chemical makes a different mark on the sheet. Okay, so you can see here you have taken like a TLC plate, thin layer chromatography plate, and you put a drop here, then you keep it in the mobile phase in your solvent, and after some time you will find that the chemicals have moved with the solvent. So this is the distance that the solvent has moved, and these are the distance that the different chemicals have moved. Okay, next, it is used to check if medicines are pure or to in the separation of chemicals. Next, we have something called as column chromatography. Okay, so imagine a tall glass tube filled with sand or bead. Okay, you can see tall glass tube filled with sand or bead. You pour a liquid mixture into the tube and the parts of the mixture come out separately at the bottom. Okay, so you can see here you have a glass tube. Okay, and this is a stationary phase, means this is the glass. This is the phase which is filled with beads or your sand particles, and now you drop your sample here. Okay, you drop the sample which you want to separate. Now in this what happens, different samples, different components will move to different extent in the column. Okay, so so you can see green color component has moved faster. Okay, then you can see this brown component is there, and then the pink component is there. Then after some time you can see the green component has moved here. It has weaker interactions, that means it has weaker interactions with this column, right? So it is moving to this one. Now if you see this one, this brown color, right, the brown color has more interactions with this column, so it remains up, right? So similarly you can see at the end the green color has collected, and finally the brown color substance is also collected. Okay, so that is based on the interactions with the stationary phase, and with the mobile phase the elements get separated. Okay, clear? Next is your partition chromatography. This is also very simple. So what is partition chromatography? It separates the substances based on how they dissolve in two different liquids that do not mix like oil and water. Okay, I'll give you an example. See, a liquid called the stationary phase is spread on a surface like paper. Another liquid called mobile phase flows through it, carrying the substance to be separated. Okay, so now you have a surface here, okay, and on this you pour a liquid, okay, and on above it you pour another liquid which contains the sample to be separated. Now what will happen? Each substance spends time dissolving in both the liquids. So there is a mobile phase and there is a stationary phase, and this back and forth movement separates them. Okay, so imagine oil and water on a plate. If you add food color to them, okay, so some colors prefer oil and some others prefer water, and then you have to separate them. Okay, so you can see an example here. You have like the organic compound in the, so you have taken oil and water suppose, and you mix the sample to be separated. So that sample will have different components. Some components will get dissolved in oil, some components will dissolve in water. Now oil and water are separate, right? Now you open and collect the organic or the aqueous layer, and you collect the organic layer separately, and then you evaporate it and you will get the components back, right? So organic compound in aqueous layer is present here and the compound is given here. So that is how it will separate, okay? Now it is used for separating dyes, pigments or chemicals in a mixture, okay? So what you have to do in this example, if you understand, it will be very clear. You can take a oil and water on one plate, add some food color to it. The food color has different components. Some components will be dissolved in oil, some components will dissolve in water, right? Now what will happen, oil and water are separated, so remove the oil, remove the water, evaporate the samples, and you will evaporate the water and oil, and you will find the samples present in that, okay? Next is solvent extraction. This is also very simple. Now see, when an organic compound is present in an aqueous medium, it is separated by soaking it with an organic solvent in which it is more soluble than in water. So you know organic compounds are generally insoluble in water. So when you have any organic compound in aqueous medium, put some like you want to take it out, okay? So put some organic solvent in that. So that organic sample, so let us see one example. I'll try to explain it through a diagram. So you have water, okay, and you have some organic sample here, okay? Now I want this organic sample from the water. So what you can do, you can add some what I can say, solvent. You can add some organic solvent to this, right? Now what will happen, this organic solvent, through this organic solvent, this organic particles will get dissolved, right? Now you know these two are immiscible. So what we can do, we can just do filtration using what? Using separating funnel. Okay, so that means what, we got this oil sample separately, or this organic solvent separately, where it is dissolved the organic compounds. So now what you can do, the organic solvent and the aqueous solution should be immiscible with each other, so that they form two distinct layers which can be separated by separatory funnel. The organic solvent is later removed by distillation or by evaporation to get back the compound. Okay, clear? So yes students, once again I want to tell you about the PU2 success blueprint test series. You knew that the price was the test series was available at $599, but as we have Christmas, something very special for all of us. So on this occasion, on this ease of Christmas, to celebrate it better, we are giving you some discount coupons. You can use the coupon code AISH100 to get flat ₹100 off, right? You will get this course at 499 rupees only, and remember, this coupon code is valid only up to 28th of December 2024. Okay, so do not miss this opportunity. Their link is there in the description section. Please go there, apply the coupon and get a discounted price and buy the test series as soon as possible. Okay, in this you will be getting 12 mock tests. Already one mock test is over. Then you will be getting so you will be able to access that one mock test which you would have missed. Okay, then you will also be getting the subjects will be PCMB and CS. You will also be getting computer science question paper. Then exam focused questions based on the latest pattern and syllabus. You will getting video solutions, as well as we teachers will be coming every week live to clear your doubts, right? So these all things you can avail just at 499 rupees, students. Now until 28th of December you have this offer, so please do not miss this. And this like Christmas, let us be more driven towards getting our success, right? Okay. So that's all students, and I hope this purification of compounds, see, it is not a very important topic, so you can like give, just you should know the methods, the principles and all. So if you just follow these notes, it is enough for you to clear this exam, KCET exam. Okay, you do not have to go in detail of each and every method, so that is not required, but a basic understanding of the purification method will help you. Okay, that's all students, and see you soon in the next class.